Happy morning. Happy morning to all. Happy morning. Okay. The last class we discussed about that. What are the main assumption? What are the main assumption of valence bond theory? It's a very important question. The valence bond theory and also the Verniers theory. Both the two theories are very, very important question for the board exam question. Anyhow, the valence bond theory having 10 points. Those who learn 10 points, you can score the 5-mark full mark, okay? Those who are not learned the question means you should be today itself, you should be learned that the valence bond theory. What are the main assumption of valence bond theory, okay? Anyhow, today we are going to discuss about that. What are the examples, which are the complex we are explaining the valence bond theory. That is, what are the examples, otherwise called, what is the applications of valence bond theory? What are the applications? We are taking 4 complex. One is NiCO 4 times. That is nickel tetracarbonate. That is one complex. Second one, NiCN 4 minus. NiCN 4 minus. It is one of the second complex. Next one is FeCN6 3 minus. FeCN6 3 minus. That is a third complex. That's CO F6 3 minus. It's a fourth complex. Here, what we are going to write means, what we are going to discuss means, first the electronic configuration, next about the orbital diagram, electron occupation, orbital, next about strong field or weak field, low spin or high spin, okay. That means geometry, hybridization, coordination number, very, very important point, coordination number, hybridization, geometry, and also magnetic property, whether it is a diamagnetic or paramagnetic. It's a very, very important. That is a complex is a diamagnetic and it's a paramagnetic. Why it is a diamagnetic and why it is a paramagnetic? And also explain the mu, magnetic moment. Have one formula, mu s is equal to root of n into n plus 2. These are all we are learning one by one. So watch carefully today's video. If you watch carefully, then only you can be able to understand what is the concept of that complex. Okay. Anyhow, please all of you take your note. We can be write the application, the examples of valence bond theory. Please all of you take the note. Shall we write? Okay, let us begin to discuss what are the examples. What are the applications? We can see the applications also. What are the examples of VB theory? We are taking some complex, that is NiCO 4 times. Okay, this is one of the complex. Okay, that is nickel tetracarbonyl, etc. Okay, so the name. First, here, what are we going to discuss means, here about the nature of ligon, hybridization, geometry, magnetic property, and magnetic moment. Okay, these are the topics we are going to discuss by means of this complex. First one is nature of ligon, about this complex. Next about that hybridization, coordination number, and about the geometry, magnetic property, magnetic moment. By use of this VB theory, that is valence bond theory. Here, which one is the central metal atom? Nickel is the central metal atom. Nickel, am I right? Nickel is the central metal atom. And about what is the configuration of nickel? That is, the many times we learn about the electronic configuration, how we write the electronic configuration. Many times we will learn. Okay, this is not time to learning now. Okay, those who are not learned how to write the electronic configuration means you just watch the previous video. Anyhow, the atomic number of nickel is 28. What is the atomic number of nickel? 28. the electronic configuration EC is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. Okay, the outer is completely filled. Okay, so 3d8, 4s2. Anyhow, electronic configuration. Here, D subshell is not filled because atomic number is 28. Anyhow, the outer orbitals of metal atom. Outer orbital of metal atom. We should be draw the orbital diagram. That is D. How much electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. About the 3d8. Next about the 4s. This is the 3d. Next about 4s. How much electron? 2 electron. Next about 4p. You should be draw the 4p. 4p, there is 0 electron, there is no electron. Okay, this is the outer orbital of metal atom. Alright. About the nature of ligand. What is the nature of ligand? We are taking nature of ligand. Here, cobalt is the ligand, am I right? Sorry. Carbonyl. Carbonyl is the neutral compounds. Carbonyl is the ligand. Here, strong field ligand causes the pairing of 4s electron. Here, strong ligand, this is the strong ligand. Here, pairing takes place in the D subshell. D. The 4s electron having 2 electron. This 2 electron is paired in the D subshell. So, here I have some vacant, am I right? That means the strong field ligand causes the pairing of 4s electron with a 3d electron in the metal. With a 3d electron in the metal. So, here the pairing takes place. Okay, pairing. Okay. So, can you say what is the configuration? What is the outer orbitals, atoms are present in the ligand? What is the configuration means? You should be write this. Okay, once again. Actually 1, 2, 3, 4, 5, 6, 7, 8. Okay, 3D having 8 electrons. Am I right? 3D8. Okay, 3D8. The 4 electron will be attached here. So the 2 electron from 4s electron. The 2 electrons also attached will be here. So 4s having some vacant. 4s 0 electron and also 4p also. 4p also 0. Can you understand? Did you understand anything? I told you that as per the electronic configuration of nickel is 3d8 4s2. The 4s electron is shift to where 3d subshell. So now it have some vacant. Here is completely filled. Okay, it's a completely filled. Next about the hybridization. Here having 4 vacant, this 4 vacant, this carbonyl group is attached here. Okay, here having 4 vacancy, am I right? 4 is having 1, 4p having 3. So 3 plus 1, 4. The carbonyl group is attached here. So the hybridized orbital of the metal atom in the complex. Hybridized orbital. That means D subshell 4s 4p, am I right? 3D subshell 1 2 3 4 5 6 7 8 9 10 3D. Okay, 3D is completely filled. Okay, that is 3D 10. About the 4s, here having how much vacant is there? Here having 4 vacant. The 4 vacant, that 4 ligand will be attached here. 4 ligand, am I right? There is one is here. One of the ligand. then second ligand, third ligand, and fourth ligand. Okay, we can be changed with one of the blue. Okay, change it can be blue. This is the 4s, 4s, 4p, carbonyl group, carbonyl second one, carbonyl third one, carbonyl fourth one. So now what is the hybridization? What is the hybridization? One of the s orbital combines with 3p orbital to form sp3 hybridization. What is the hybridization? sp3 hybridization, and the coordination number is what? 4. Here are the coordination number is what? 4. The hybridization is sp3. Okay, here. So in the valence bond theory, I think that after the 6th point, in the valence bond theory, after the 6th point, that means I think that the hybridized orbital are directional and their orientation in space is given as a defined geometry to the complex ion. After that, we have a tabular column. In that tabular column, explain about that the hybridization, geometry, and also coordination number. Am I right? Here the coordination number is 4. Can you say what are the hybridization? 2 hybridizations are possible. One is sp3, another one is dsp2. Okay, but we got a sp3 hybridization. So what is the geometry? Means tetrahedral. Geometry what? Tetrahedral. What's the geometry? Tetrahedral is our geometry. Am I right? Here we should be calculate the magnetic property. We should be calculate what? The magnetic property. Magnetic property can be calculating. Have one formula. What is the formula means? Having number of unpaired electron. How much unpaired electron is there? This should be calculated the number of unpaired electron. Okay. Here, this is it paired? Paired electron, paired electron, paired electron, paired electron, paired. Everything are all paired electron. So the number of unpaired electron is 0. Number of unpaired electron. Unpaired electron is 0, hence it is a diamagnetic. Diamagnetic. Why it is a diamagnetic? Here all electrons are paired. Okay, so how can you calculate the magnetic moment? How can you calculate the magnetic moment? That is one of the formula. What is the formula? Mu is equal to root of n into n plus 2 Bohr magnetron. That is just right. The symbol. Okay. Then here, what is about the n? N is the number of unpaired electron. Am I right? N is the number of unpaired electron. So unpaired electron is 0. So what is the answer? We get is equal to 0. What is the answer? 0. Okay. So the magnetic moment, there is a using a formula. What is the formula? Mu is equal to mu s. We can use the mu s is equal to root of n into n plus 2. Mu s is equal to root of n into n plus 2. So here the number of unpaired electron is 0. So what is your answer? We get the 0 is the answer because all electrons are paired. Am I right? So this is the application or this is the examples of VB theory. Number 1, first complex, that is NiCO4. That's a very important question. Next about that, we can be taken on another one example. What is that example means? That is NiCN4 4 minus. Another one example. Did you understand about this one? It's a very important question. If you haven't doubt, please call me. Okay. Next one. Ni is CN4 minus. NiCN4 4 minus. This is the next complex. Here we are using one of the ligand is what? Cyanide. Okay. NiCN4 4 minus. This is one of another complex. Here also the complex we wrote here. Central metal atom ion and its electronic configuration. Which one is the central metal atom? Nickel. Nickel is the central metal atom. Nickel is what? Central metal atom. Okay. Here we are going to take the atomic number of nickel is 28. Electronic quantity EC is equal to 1s2, 2s2, 2p6, 3s2, 3p6. Okay. 4s2. Am I right? Nickel 28, 10, 80. Next about 3D. 10, 80, 3D8 first. Okay. 3D8 first. Okay. Anyhow, here the ions, that is Ni2 plus ions. Ni2 plus. How will you take the Ni2 plus? That means the loss of 4s electron. Am I right? 4s becomes 0. So what is the configuration? It is 3D8 4s0. 3D8 4s0. This is the configuration of Ni2 plus ions. Am I right? So we should be write the outer orbitals of metal atom. Outer orbital. Ion. How will you write the outer electronic configuration? Okay, first you should be write 3D8. 3D8. Okay, 3D8. How much electron is there? 8 electrons. 1, 2, 3, 4. 5, 6, 7, 8. 8 electron. 3D8. 4s having 0 because nickel 2 plus ion. And about 4p, that also 0. Am I right? That also 0. Nature of the ligand. What is about the nature of ligand? Cn minus. Okay. Cn minus. Strong field ligand cause the pairing of 3D electron in the metal. Here the pairing takes place. Okay. Here what is the pairing takes place means here having 2 unpaired electrons. It should be paired here. Here it should be paired here. So what is the configuration? Can you say what's the configuration? That is outer orbital metals, atoms or ion present in the ligand. The ligand, what is the configuration? So we get okay, here these electrons will be paired here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the vacant orbital 3D8. Am I right? 3D8. It's a vacant orbital. Okay. Now, anyhow, the next step is you should be find out the coordination number and also hybridization. Here, the next to the pairing is start with the D. Am I right? Here, how much cyno group is there? Cyno group is a powerful ligand. Am I right? Powerful ligand. This powerful ligand should be paired in the D subshell. Okay? Here having 2 singly filled electrons is there. It should be paired here. Because it is a cyno group. Only cyno groups maximum is a pairing takes place. Okay. Anyhow, from the vacancy where? From the D subshell we have the vacancy. So hybridization start with here. D having 1 vacancy. Next about 4s. Next about the 4p. Am I right? 4s, 4p. So next we should be write the hybridized orbital. Okay, hybridized orbital of the metal atom. In the complex. In the complex, okay. How will you draw this structure? Here means 3D having 4, am I right? 1, 2, 3. Next. This is the one of, that means here electrons are over 1, 2, 3, 4, 5, 6, 7, 8. 7, 8 over. That means D having 5, subshell, am I right? That is 4 is over, remaining starting with 1 here. 1. Next about the 4s. Next about the 4p. 1, 2. Okay, here. 1, 2. 1, 2. Okay? Next, what is about the hybridization? Here, hybridization. That means here are the 4 cyano group. This is a D, a D1. This is S. This is P. That is PX1, PXY. Otherwise, can be written as 4PX, 4PY, 4PZ. Am I right? Okay. Here, D subshell starting cyano group 1, 2, 3, 4. So, what is the hybridization? Can you say what is the hybridization? S, P2 hybridization. What is the hybridization? DsP2 hybridization. Okay. That is, what is the coordination number of DsP2 hybridization? That is a 4 coordination number. That is, the coordination number is what? Cn is equal to 4. So, DsP2 hybridization means it is a square planar. Which planar? Okay. DsP2 which one? Square planar. Okay. Square planar. And about you should be find out that the number of unpaired electrons, that is about the magnetic property. Here geometry is square planar. Geometry is square planar. You should be find out the magnetic property. How much number of unpaired electron? Unpaired electron. There have any unpaired electron? All electrons are paired. Am I right? There is no unpaired electron. All electrons are paired. So it is a diamagnetic nature. Which nature? Diamagnetic. Diamagnetic nature. So you should be find out the mu. Mu is equal to root of n into n plus 2. Root of n into n plus 2. Here there is no unpaired electron. All electrons are paired. So we cannot find the Mu's value. That Mu's value equal to what? Equal to 0. Equal to what? 0. This is about the second example. Then what is about the third example? We are taking one more complex. Third example. FeCN6 3 minus FeCN6 3 minus. This is another complex. FeCN6 3 minus. Here the central metal atom or ion in its electronic configuration. What is the central metal ion? That is Fe. What is the central metal ion? Fe ion. What is the atomic number of ion? 26. Okay, what is the atomic number of ion? 26. But here having 3 plus, because we are having 3 minus. So Fe3 plus. Okay, Fe3 plus means it should be loss of 3 electron. Am I right? Loss of 3 electron. So the atomic number, the electronic configuration should be right. Ec is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 6 4s2. Okay, shall we count that one? 4 plus 10, 6, 10, 12, 18, 20, 26. Okay. Here Fe3 plus means it loses 2 electrons from 4s and 3d electron 1. Okay, 1 electron loss from 3d, 1 electron loses. So what is the configuration means? Is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s0. 4s0. This is the electronic configuration. Okay, 4s0. Here loss of 3 electron. 3 electron means the atomic number means 23 becomes 23. So how will you write? How will you take? From 4s 2 electron and 1 more electron from 3d. So we get 3d5. 3d5. Then we should draw the outer orbitals of metal atom. Outer orbitals. Of metal atom. Outer orbitals of metal atom. Okay? How will you draw the outer orbitals? Okay. We can draw about the outer orbital, that is D subshell, that is a 3d5, 3d5, 3d 5 electron. 1, 2, 3, 4, 5. 3d5. Next about the 4s there is no electron. 4s 0. And 4p also 0 electron. Here, am I right? Here, what is happening here? Strong field ligand causes the pairing. Here, strong field ligand. Cn is the strong field ligand. Don't forget. So what happened here? Here, this electron combines joined to here. So here having vacants. This also joined to here. So here also having vacants. So can you say what is the configuration? Can you say what is outer configuration? FeCN 6 for 3 minus. This electron combines here, so we get 2 electron. This electron combines to here, it's also 2 electron. That single electron having 1 single electron. Total how much electron is there? 1, 2, 3, 4, 5. 5 having. Here having 1, 2, 3, 4, 5. Here. So 3d5. What is the configuration? 3d5. Does 4s having electron? No. 4s 0. 4p also 0. So anyhow, it is a powerful ligand. Cn is a powerful ligand. It is a strong ligand, strong field ligand, causing pairing of D, 3D. Okay, it pushes the electron. Okay, so its pairing takes place. Pairing takes place here. Anyhow, we should draw the hybridization. How much cyano group is there? Cyano group, how much? 6. So how much vacancy is there? 1, 2, 3, 4, 5, 6. How much vacancy? Once again, 1, 2, 3, 4, 5, 6. This 6 cyano group will be attached here. Okay. Next again should be drawn. One, 2, 3, 4, 5. 4s, 4p, 4p, 4s, 3d5. Okay, here 3d5. Now, what is the configuration? Okay, that is 1 cyno, 6 cyno, 1 cyno over, 2 cyno over, 3 cyno over, 4 cyno over, 5 cyno over, and 6 cyno is also over. Now what is the hybridization? What is the hybridization? How much D is there? D2. D2. Okay. 1 yes. D2 yes. How much is P? 3P. So what is the hybridization? D2 sp3 hybridization. What is the hybridization? D2 sp3 hybridization. So here what is the coordination number? 1, 2, 3, 4, 5, Cn is equal to 6 coordinate number. So D2sp3 hybridization. We know that what is a geometry means? It is an octahedral geometry. What's the geometry? Octahedral. Okay. Here, one of the important point, the geometry in this complex, the d orbitals are involved in hybridization. In this geometry, okay, the d orbitals are in this complex, the d orbitals are involved in hybridization, and hence the complex is called inner orbital complex. Okay, here what? Inner orbital complex, because the reason what? In this complex, inner d orbitals are involved in the hybridization. Inner d orbitals are involved in the hybridization, and hence the complex is called what? Inner orbital complex. Inner orbital complex. Okay, inner orbital complex. Okay, here then you should be find out the magnetic property. Very, very important. The magnetic property mu S is equal to root of n into n plus 2. Here, how much unpaired electron is there? Only one unpaired electron is there. Am I right? How much unpaired electron is there? One unpaired electron. So, root of 1 into 1 plus 2. Can you say what's the answer? We get 1 into 1 plus 3. What's the answer? Take root 3. The answer is about 1.732 Bohr magneton. Okay? Bohr magneton. Okay? This is the answer. Can you learn? Next about the last one down, the last one more complex. COF6 3 minus. Okay, COF6. COF6 3 minus. This is another complex. Here, the central metal atom and its electronic configuration. Which one is the central metal atom? Cobalt. Okay, cobalt. Cobalt is the central metal. Okay. What is the atomic number of cobalt? 27. Okay. How will you write the electronic configuration? That is EC is equal to 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Okay, 3d7, 4s2. Here CO3 plus, because they are given 3 minus, so we should be write CO3 plus. Here loss of 3 electron. Okay, that is 4s electron 1, and here 3d from 1. Here 4s electron how much? 2, and about 3d should be 1. So what is the configuration? Okay, how will you write the configuration? We should be write the configuration 3D. First to first to write the try to count the atomic number 10, 12, 18, 18 plus 20, 27. Okay, got it. 3 plus means loss of 3 electron, that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. Okay, what's the configuration? 3d6, 4s2. Okay, sorry, 4s2 is leaving out. 3d6, we get 3d6. Then, how will you write that orbital diagram? How will you draw? That means we are taking 3d, 3d6, how much electron? 1, 2, 3, 4, 5, 6 electron. Okay, next what? 4s, there is no electron. 4s 0, and 4p, there is also no electron. 4p 0, no electron. Here about you should be say about the hybridization. How much fluorine atom is there? There is a 6 fluorine atom. How much fluorine atom is there? 6 fluorine atom. The 6th fluorine atom will be bond where? Bond where means because it is a weak ligand. It is not a strong field ligand. It's a weak ligand. It cannot be paired the d orbital. Okay, here it cannot be paired in d orbital. So it will be start from 4s. Okay, again you should be draw another one orbital. This is a 3D. 3D is 6. 4s. 4p. Next you should be draw 4D. Okay. Here having how much electron? 1, 2, 3, 4, 5, 6. This is over. So this is over. This is over. How much vacant is there? 1, 2, 3, 4, 5, 6. Clear? 5, 6. So what's the configuration? Can you say? Here, what's the configuration? Here having 6 fluorine atom is there. One of the fluorine atom is attached here. Second fluorine, third fluorine, fourth, fifth, sixth. So what is the configuration? Can you say what is the configuration? What is the configuration? Can you say what is the configuration? One s orbital. How much p orbital? 3 p orbital. And how much d orbital? 2 d orbital. sp3d 2 hybridization. What is the sp3d 2 hybridization? What is the geometry? That all of you know that one. The geometry is what? Octahedral. Octahedral. What is about the coordination number? Coordination number is what? It's 6. 6 is the coordination already we learned. And about here you should be write the magnetic property. That is to do magnetic property should be find out. Because number of unpaired electron how much? Here also 1, 2, 3, 4 unpaired electron. Number of unpaired electron is equal to 4. So we cannot be say it is a what? We cannot be say it is a diamagnetic. It is a paramagnetic because here having number of unpaired electron. Number of unpaired electron means it is a paramagnetic. There is no unpaired electron. All electrons are paired. It is a diamagnetic. Clear? So we should find out the mu calculation. How can you find out the mu calculation? Magnetic moment, that is mu s is equal to root of n into n plus 2. So n means number of unpaired electron 4. Can you see what is the answer? Root of 4 into 4 plus 2. Okay. That is we get about that 6 into 24. Am I right? So 6 versus 24 we get is equal to approximately equal to 4.8994 magnetron. Okay. This is about the magnetic moment of this complex COF6. Okay. Next about you should be learn about the limitation. Anyhow, this VB theory having some limitation. That also you should be learn what are the limitation. The limitations also important point, important question. What are the limitation of valence bond theory? Limitation of VB theory. Okay. Limitation. What are the limitation? Here, it does not explain the color of the complex. It does not explain. Okay. Explain the color of the complex. Does not explain the color. He explained about that. What are he explained about that? First one, electronic configuration, nature of ligand explained, and about the whether it is a weak field ligand or strong field ligand. Strong field ligand means these subshells are paired, weak field ligand means there is no pairing in the 3D electrons. Am I right? There is no pairing in the 3D electron. So it explains about the strong field and also weak field. Anyhow, okay. And also it explains about the coordination number. It explains the hybridization, geometry, everything is okay. And explain the magnetic property, magnetic moment, everything is okay, everything is good. But one of the limitation, it does not explain the color of the complex. Color does not explain. Okay. Then it considered only spin only magnetic moment. Okay, it considered spin. It considered only spin only magnetic moment. Does not consider the other component of magnetic moment. It does not consider the other component of magnetic moment. Okay. It consider only what? Spin only magnetic moment and does not consider the other component and does not consider other component of magnetic moment. Okay. Anything 2 point is enough? Okay. Those who are interested, you should be learned the third one also. First one is color, second one is spin only magnetic moment. Okay, that's not okay. First one, it consider only the spin only magnetic moment and does not consider the other component of magnetic moment. And also, it does not provide the quantitative explanation. Quantitative explanation as to why certain complex are inner orbital complex and other outer orbital complex for the same matter. That also does not explain. For example, we now only learn that FeCN4 minus is a diamagnetic, it is a low spin, whereas Fe6 is a paramagnetic, it is a high spin. It does not provide the quantitative explanation as to why certain complex are inner orbital and certain complex are outer orbital. Okay, why certain complex are inner orbital complex, why certain complex are outer orbital complex in the same pattern. For example, what is that one? One is a diamagnetic and another one is a paramagnetic. Okay, for example, FeCN6 minus is a diamagnetic. Okay, because all electrons are paired there, so it is a diamagnetic. And about that, Fe6 minus is a paramagnetic. Here, some unpaired electron having it is a high spin. Okay, the three limitation. Okay, there are three limitation. Anyhow, tomorrow assignment. Right, any two complex. They are having four complex. I gave four complex assignment. Any two complex. Okay, any two complex, you should be right. For example, what are the complex there? Can you say what are the complex? First one, NiCO 4 times. Am I right? NiCO 4 times. Next one is NiCN 4 times 4 minus. Next one is FeCN6 3 minus. Next one is CO F6 3 minus. These are the four examples. Anyhow, you should be right. Any two of the complex. Okay. Thank you all of you. Thank you. Have a nice day.